Today, we're cracking open the actual blueprints that the world's biggest industries use to build their data systems. We're going to see exactly how companies in retail, banking, healthcare, and more are architecting their massive cloud platforms. Let's dive in.
So, here's our game plan. First, we'll talk about why there's really no such thing as a best architecture. Then, we'll take a tour of the specific blueprints for different sectors, from retail to finance to healthcare. After that, we'll compare all the designs side by side, and we'll wrap up with the one golden rule every data architect has to live by.
Do you ever stop and wonder about this? How does your bank manage to stop a fraudulent transaction in milliseconds? Or how does that online store seem to know exactly what you want to buy next? Well, the answer to both is something called data architecture. It's this powerful, invisible engine running behind the scenes, and its design changes completely depending on the job it has to do.
And that leads us right to our first and maybe most important point. When you're building these incredible data systems, there is just no one-size-fits-all solution.
Here's the bottom line. The business problem always dictates the technology. Think about it. A bank's absolute need for split-second fraud detection. That requires a totally different setup than a healthcare provider's need for ironclad Fort Knox-level data security. It's all about a balancing act between regulations, the need for speed, and just how complex the data is.
Okay, so let's kick off our tour with a couple of industries we all deal with pretty much every day: retail and banking.
First up, retail and e-commerce. We all know it, we all use it, and its most powerful, most recognizable feature has got to be the recommendation engine. That little box that says, hey, you might also like this, that thing is a true data engineering marvel.
And honestly, that's just the tip of the iceberg. Retailers are using data to get a complete 360-degree view of their customers, to forecast demand so the stuff you want is always in stock, and of course to send you those perfectly timed, personalized offers.
So let's follow the data's journey here. It all starts with every click you make, every purchase. Those are captured as events and streamed into a system like Kafka. You can think of Kafka as the central nervous system for all of the company's data. From there, that raw data gets stored and then transformed using a powerful engine like Spark to get it all cleaned up. Then it lands in a massive data warehouse. And that's where the magic happens. Analysts build dashboards, and AI models start generating those smart predictions.
And look, this isn't some obscure niche thing. This exact blueprint, from a raw click all the way to an intelligent prediction, is probably the most common data engineering pattern you're going to find out in the real world. It's everywhere.
All right, let's totally switch gears and jump over to banking and finance. Here, the focus isn't on what you might do next week. It's all about what's happening right now. And the killer app? It's real-time fraud detection.
And the stakes here are just incredibly high. We're talking about more than just fraud. These systems are crucial for figuring out credit risk, monitoring for things like money laundering, analyzing split-second trades, and even using AI to automatically pull information out of complex financial documents.
So, the banking blueprint, it also kicks off with data streaming into Kafka. But, and this is the huge difference, a tool like Flink processes that data the instant it arrives, in real time. This is called stream processing. The data is immediately stored, fed into risk models, and constantly monitored. There's no waiting around for some overnight job. This all happens, boom, instantly. And this really gets to the heart of it. The entire process, from the moment you swipe your card to the system flagging it as potential fraud, has to happen in under 200 milliseconds. That is literally faster than you can blink. And why so fast? Simple. If it's any slower, the fraudulent transaction might go through before the system can stop it. So for finance, a streaming architecture isn't just a cool feature. It is absolutely non-negotiable.
Next up on our tour, we're looking at two industries defined by some pretty unique challenges: healthcare, with its intense regulations, and telecom, which is just dealing with a constant flood of data from our connected world.
In healthcare and pharmaceuticals, everything starts and ends with security and compliance. Seriously, protecting patient data isn't just a goal, it's the law, and that fact shapes every single technology choice they make.
But if you get that security piece right, the payoff is just immense. The architecture here is all about creating these highly secure data lakes of medical records. This allows for incredible stuff like building AI models that can help predict patient diagnoses, analyzing clinical trials way more effectively, and even speeding up the process of drug discovery. The whole design prioritizes governance above all else.
And this is the key point, right? The regulatory burden is massive. You've got laws like HIPAA in the US and GDPR in Europe, and they are completely non-negotiable.
So the architecture has to be built from day one to track where every piece of data came from and to guarantee privacy.
All right, now for telecom. This world is all about managing a fire hose of data. I mean, just try to imagine the billions of data points being generated every single second by our phones, by cell towers, by all those connected IoT devices. The architecture here has to be built to handle this massive scale of telemetry and location data.
And they use all this data to solve really critical problems, like analyzing call logs to improve service, or detecting network faults before they cause a huge outage. And you can probably guess, much like banking, this requires a real-time streaming architecture to process that constant flow of information and react to network issues in seconds, not hours.
For our final stop, we're shifting from the purely digital world into the physical one. We're going to explore how manufacturing and supply chain companies are using data to totally revolutionize how they operate.
The flagship use case here is something called predictive maintenance. Basically, companies stick sensors all over their factory machines. These sensors are constantly collecting data on things like temperature and vibration, and all that data gets fed into a system that can predict when a machine is likely to fail before it actually breaks. And this isn't some futuristic concept, you know? It's happening right now. This combination of sensor data, AI, and data engineering is one of the absolute hottest, fastest growing areas in the entire field. And for good reason, it saves companies millions of dollars in downtime and repairs.
Okay, we've just done a whirlwind tour of 5 very different industries. Now it's time to zoom out. Let's pull them all up side by side and see what kinds of patterns and connections just jump out at us. So, when you put it all together, how do these different needs and constraints really stack up against each other? Let's take a look.
This table really connects the dots perfectly. Just look at retail up top. See that low for compliance? That gives them a ton of flexibility. Now contrast that with healthcare. Very high. That one requirement changes absolutely everything. Now look over at the real-time need column. Banking and telecom are high or very high. No wonder they both lean so heavily on those streaming architectures we talked about. You can even see patterns in which cloud providers they tend to prefer, which is often driven by a platform's strengths in things like security or analytics.
All of this brings us to the final and most important takeaway of this whole explainer. You could call it the architect's golden rule. Let this one sink in. There is no magic bullet. There is no single best data architecture, period. The right choice is always, and I mean always, the one that is purpose-built for the specific industry and the specific problem you are trying to solve.
So to recap, for finance and telecom, speed is everything, so streaming is king. For healthcare, security is paramount, so governance is the foundation. For manufacturing and logistics, it's all about that geospatial and sensor data. For retail, understanding the customer drives everything. And the one common thread through all of them, machine learning pipelines. They're not an optional add-on anymore, they are standard equipment across the board.
And this leaves us with a final thought to chew on. These blueprints aren't static. They're constantly evolving with new technology and new challenges. So as AI gets more powerful and data becomes even more critical, the real question is, what will the next generation of these blueprints look like?